Hello, this is Dr. Donna Burnett. In this lesson, we'll learn about flours and flour mixtures. Let's get started. By the end of this chapter, you should be able to explain flour composition and the functions of its starch and protein, outline unhealthy reactions to cereal grains or their flours and how they differ, list the 5 major steps of milling flour, discuss the various classifications of flours and how wheat flours can be classified by protein content, summarize the various ingredients and functions in flour mixtures, define the differences between doughs and batters, changes during heating and high-altitude adjustments, and provide instruction on how to best store flours. A flour is a fine powder made by grinding the endosperm of cereal grains. It's primarily derived from wheat, although it can also be made from oats, rye, barley, rice, and corn, as well as non-cereal sources such as soybeans, potatoes, nuts, and starchy fruits and vegetables. Flour in crude bread forms have been around for about 10,000 years. Flour mixture ingredients would be dry ingredients and liquid ingredients that you would combine. So for the dry ingredients, you would have your flour plus whatever leavening agent, if you were going to use one, sugar, salt, and flavoring. They each have their own roles to play. And liquid ingredients could be water, milk, fat, eggs, or a combination. Remember from chapter 16 that starch will gelatinize under certain conditions, such as the correct heat and the presence of liquid. So when the starch gelatinizes, that adds strength to the baked items, and it contributes to the crumb. The crumb is the cell structure that you see when you slice a baked product into and look at the texture. Starch can be partially broken down by enzymes into dextrin, malt, and glucose, and you also learned about that in chapter 3. Gluten is the protein that contributes to the firmness of flour mixtures. Sugar and fat happen to be tenderizing agents. The ability of baked products to rise is directly related to protein content, and as we will learn, different types of flour have different amounts of protein, so the more protein you have more ability to rise and provide that structure. Wheat flour has the highest concentration of proteins that form gluten, and that makes it the most preferred flour. Gluten is formed by the combination of 2 wheat flour proteins, gliadin and glutenin. Here's your gliadin, here's your glutenin, which is fibrous. The gliadin is globular, and together they make gluten. Over here on the left, you see about 85% of the wheat flour proteins can form gluten. 15% would be non-gluten or non-dough forming. And these numbers depend on how much gliadin and glutenin exists in the flour. Over here you see the elasticity of glutenin and the gliadin's fluidity and stickiness, and together they form gluten's consistency, which if you've ever made bread, you probably recognize this. It stretches, and that's what we need it to do because we want it to trap air in the product and then set up to form the structure. The purpose of gluten, therefore, is to trap the gases. This can be steam, can be the product of your leavening agents. The gases rise, the gluten traps the gases and sets up, because as protein is baked, it will set up to a rigid structure. The texture is going to depend on how much gluten there is, and you also can separate the gluten from the flour. So steps to gluten formation would be definitely hydration. You combine those by kneading, which is applying pressure to the mixture. You can dry the gluten and then sell it as wheat gluten, and it can be used in textured vegetable protein. This is what we're talking about here. So the proportion of gluten derived from cake flour is at the top. It's the smallest ball because it will be the most tender. It's going to have the least protein. At the bottom, we have bread dough or bread flour, and this will form the most protein because it has the most gliadin and glutenin. And in the middle, we have what we call all-purpose flour, which is a combination of cake flour and bread flour. We have soft wheat and hard wheat. And then the baked product behind it shows you what happens when it's baked, and you can see the difference. The cake flour will be the smallest, the bread flour will be the largest, and the all-purpose flour is right in the middle. Now, how did they get the gluten out separately? They ran it under water, under cold water for some time, and the starch separated from the protein. Here's a little bit more information about how the dough is developed by kneading. So you have the gluten here, you have the water here, the lipids are in the center, which we would call here the slip plane. And you see they take the dough mixture and then start applying pressure through kneading. You'll learn more about kneading, perhaps in your lab, but as we go along, you'll learn more here. What this is showing you here is the role of lipids in gluten development. So one theory is that the gluten proteins, which would be the combination of gliadin and glutenin, slide more easily past each other in opposite directions between lipid-containing sheets, and ultimately this contributes to proper dough expansion. Now in figure 18-8, we see an illustration of how kneading realigns protein molecules. The physical pressure of kneading stretches out the gluten molecules, cross-linked by sulfide bonds. Sheets of gluten, far right, give the dough a smooth, fine texture. Now let's check in with Chef Martin to see him bake a loaf of bread using all of the techniques we just learned.
Hey folks, it's Martin. Today we're going to dial things back a little bit. We're going to make the easiest loaf of bread you'll ever bake. If you've never made bread before, start here. Okay, so let's mix this bread. Today I'm measuring the ingredients using cup measures. It's what most of us have. It's what I grew up with. As a professional, I tend to use a scale predominantly, but today we're going to use cup measures because I think that's what everybody has, and I'm going to show you how to do that in the most accurate way possible. Most people, when they go to measure flour, what they do is they take their cup measure and they go into the bag and they make sure, they scoop it and then they shake it to get it, and then they're like, yeah, that's pretty good. The problem is that there's a lot of flour in this cup measure right now. Because I scooped and sort of compressed it as I took it out, this is a heavy cup of flour. Having a heavy cup of flour is going to throw off the ratios of what I want to have in this dough. And so the better method for getting flour out of the bag is to do as follows. First, fluff the flour a little bit. We're just going to sort of lighten it in the bag. We're mixing it with a little bit of air, and it basically means that 1 cup of flour will have a little bit less flour in it than it might if we just compress the cup as we measure. Okay, step 2. So then I dump it into the cup as opposed to pushing the cup into the flour. And then I sweep it. So I just level it off. And that is my 1 cup of flour. If you have cups and teaspoons, you want to use those. I showed you how to do that with the fluff, dump, sweep. If you have a scale, use that. 540 grams of flour in the bowl. And now let's get our other ingredients in there. I need a tablespoon of sugar, and I'm going to use my volumetric measure. And then 2.5 teaspoons of salt. 1, 2, and then 2 1/4 of yeast. Let's pause for just a second, because water is really key, not only for the way that it hydrates flour, it's what allows everything to come together and form a dough. The other thing that water does is it affects the temperature of the dough. And as we know, bread is a fermented or leavened product. If we use really cold water, those yeasts are not happy. If we use water that's boiling, those yeasts are not going to be happy. What we want is water that's in this sort of like Goldilocks zone of comfort. It feels good. It's slightly warm. We're cool in here today, so it almost feels like bath water. It's a soothing temperature. That's like my best sort of description that I could apply to it. So no cold water, no super hot water, go someplace in the middle. Usually that's about, around like 100 degrees, maybe a little below, maybe a little above, okay? So slightly warm. And then I'm just going to stir to combine. So I'm just bringing this together for just a second in the bowl. So let me just pause for a second and describe what this dough feels like. So it's slightly tacky, it's a little bit sticky, not super sticky. So kneading is one way that we can develop strength in dough. And what's the point of that? The point of that is that strength is what allows our dough or our loaf to rise to its fullest potential. So how do we knead? We put a little bit of flour down, and I'm going to take this dough out of the bowl. So you can see how if the dough sticks to the bench a little bit like that, you can see how a bench scraper can be handy just to sort of clean it up. Piece of dough down, and I like to press and then turn. So I'm pressing and then turning. And this might stick a little bit, and that's okay. You're going to see how I deal with that. So I'm pressing and turning. I'm pressing and sort of smearing a little bit, and if it sticks some, you just go in with your bench scraper. That's okay. A little bit of flour, put it back down. You're going to watch this dough go from sort of shaggy and not terribly homogeneous to something that looks smooth with a nice, pretty surface to it. So this is about 3 minutes in, and the dough is not sticking to things. It's less tacky. It has more strength. And I'm just going to continue a little bit. See how it almost bounces back? It's almost rubbery. I've developed that strength in that dough, so it's got that sort of aspect to it. Okay, so dough is finished with its sort of kneading, which is that process which develops strength. And now what we need to do is get some flavor in there. Right now we have good things. We have flour, water, salt, yeast, a little bit of sugar, delicious things. But fermentation, the process of rising, is actually where the flavor and aroma of bread is sort of developing. And so we need to take time for that. It takes a couple hours. This recipe calls for 1 to 2 hours. And so I'm going to put just a drop of oil in a bowl. And you could use the bowl that you mixed initially in. You don't have to get a fresh bowl. And then place the dough in there. I put it in and then I turn it once just to make sure that it's sort of moist on all sides. And then, and this is important, you want to cover the bowl, and you could either do that with a bowl cover like this, or you could use a sheet tray, a baking tray, something like that. And then you want to put it in a place which is conducive to rising. And so if it's a cold day, you don't want to put it outside on the porch, You want to put it in a place which is warm. You can put it in the oven with the light on, or find a warm spot in your house where it can rise. The dough should feel coddled or swaddled a little bit. It should feel like it's in an ambient condition, which is, I would say around 72 up to 75, depending on where you are. Okay, so happy nappy, sleep well. We'll see you in 1 to 2 hours. So the dough has risen. It's been about an hour, a little bit over, in a nice, comforting, warm, ambient condition. If I were to press on it, it kind of holds the impression of my finger. It feels marshmallowy almost. And that's a good term to sort of look for when we go and we're proofing the final loaf as well. And so I'm going to put just a little bit of flour down, and it should just fall out real nicely. Look how beautiful that is. So just a little bit of flour on top, and I'm just going to pat it to remove any large bubbles. And then I'm just going to divide it into 2 pieces. You could use a scale and get an exact divide, and most of the time that's what I'm into, but we're keeping it easy here, so I'm just going to eyeball it and just roughly get it into 2 pieces. And that's pretty close. That one looks a little bit small. Take a little bit from that guy, put it over there. Good. Okay. Patting gently to remove any bubbles. And then I'm going to fold it into a letter. And I'm patting to seal. That's about it. I'm going to elongate it just a little bit. Right now it's just like a little bit stubby. And so in order to elongate it, I'm going to just get some of my bench flour out of the way. If you've got too much flour on the surface, one of two things could happen. One, the raw flour will get incorporated into the loaf, and then when you slice it, you see this sort of like white streak. We don't want that. The other thing is that too much flour on the bench sort of makes it sort of that it slides around too much when we're trying to shape it or roll it back and forth. And what I want to do is just elongate this slightly, just out a little bit. And so in order to do that, I'm just going to roll it back and forth with both my hands. That's literally it. We've shaped our first loaf. Done. And now I'm going to put them on a tray, and we're going to let them fill with air again. That does a couple things. One, it allows them more time to gain more flavor. And two, it also will help them with their sort of final size when they come out of the oven. So we're going to let them rise one more time, and we're going to let them rise on this sheet tray. And I'm going to put a little bit of cornmeal down. You could also use semolina if you wanted to. So just a little bit of cornmeal. And the cornmeal is for flavor, it's for a little bit of crunch, and it'll also help the loaves release when they're done baking. One loaf. And the second loaf. And I'm trying to kind of make them roughly the same size. The reason for that is that as they bake, if they're the same size, they'll bake more evenly. So that's why I have some attention to detail in terms of the shaping and the sort of equal size of loaves. And while they're proofing, we want to, again, put them in an ambient condition which is comforting for them, which is moderately warm, 72, 75 degrees if possible, and cover them. If the skin dries out, the bread will not be as good, so cover them. A food-safe plastic bag, a sheet of cling film, something like that in order to keep them from drying out on the surface. Okay, we'll see you soon. Okay, so these loaves have risen a little bit. It's been 40 minutes, 45 minutes, something like that. Basically what I'm looking for is for them to inflate slightly and to feel like they have lightened, like they're slightly filled with air. They're not so proofed or so sort of pumped up that when I press them, my finger holds the indentation. It's popping back just a little bit. So this to me says that we're in the window. We're about where they need to be in order to bake. And so I've got my oven preheated, and I'm going to dust them with a little bit of flour, and then I'm going to score them with this knife. I'm using a serrated knife, which I think does a better job, and I'm just going to be quick. And that's basically helping the loaf to expand in a controlled way, because we know that once it goes in the oven, it's going to grow some more, right? So cutting it is not only decorative, but it's also functional. So here are our loaves. They're well colored. They rose well in the oven. You'll see on the video that we steamed a little bit. I added a little bit of steam during the baking process, which not only helps with browning, it also helps with the quality of the crust. It's not entirely necessary. Don't worry about that. If you are new to this process and you want to sort of keep it streamlined, you can bake without steam and it's just fine. So I'm excited to cut into this. We're going to give it a few minutes. Don't cut that bread as soon as it comes out. It's still baking. It still needs time for some of the moisture that's on the interior of the loaf to migrate out. It's still baking right now, even though it's not in the oven. So let it cool down at least, half an hour to an hour, something like that. So for literally less than an afternoon's worth of work, we've got a delicious, beautiful loaf of bread. Love the color, love the flavor. The crumb is not super widely open. It's about what I'd expect for a dough of this hydration and consistency. It's easy, it's approachable. If you haven't made bread before, try this out. It's the easiest loaf of bread you'll ever make. If you haven't made bread, this is a great place to start. Remember the things that we discussed. Measure your ingredients as accurately as possible. Make sure to warm that water up and manage your fermentation a little bit. And then once it's proofed, go ahead and load. Bake it fully for best color, and then cool it a little bit, slice it up, and enjoy this beautiful thing that can be made in the space of an afternoon. Cheers and happy baking.
Cereal grain food sensitivities include baker's asthma, wheat allergy, celiac disease, and non-celiac gluten sensitivity. Baker's asthma is caused by inhaling flour particles. For a wheat allergy, symptoms like rashes, breathing difficulties, and anaphylactic shock are possibilities if you're allergic to the wheat, which you would be allergic to the protein in the wheat. Celiac disease is an autoimmune disorder where the body attacks gluten, leading to intestinal damage. And then non-celiac gluten sensitivity affects about 6% of the U.S. population who have symptoms similar to those of celiac disease. So what does gluten-free mean? Foods can be labeled gluten-free if they contain less than 20 parts per million of gluten. Gluten-free excludes any products containing wheat, rye, barley, or their derivatives. The term also applies to fresh foods naturally free from gluten, such as meats, fruits, and vegetables. And despite perceptions of being a dietary fad, many individuals rely on gluten-free diets for serious health reasons. Now let's talk about milling the flour. Figure 18-9 shows different types of stone mills that are used for grinding grain. Figure 18-10 shows you machine milling. Rollers are used to separate the grain's endosperm from the bran and germ. There are 5 steps in milling: breaking, which you see in 1810, it shows you brake rollers, purifying, reducing, sifting, and classifying. Wheat is classified by the percent of protein content and mineral content. Table 18-1 shows the percentage protein of various wheat flours. You'll notice the asterisk there shows you, and I mentioned already, as protein increases, so does the hardness of flour. So we have hard wheat, soft wheat, and all-purpose, which is a combination. So gluten itself is 41% protein. Whole wheat and durum wheat, which is used for pasta, are considered hard wheats, and so is bread flour. Pastry flour at 9%, and cake flour, which is the softest, at 8%. Table 18-2 shows you gluten-containing flours, and is categorized by wheat, treated wheat, and non-wheat grain. The question of oats, whether that category would be gluten-free, depends on the variety of oat and whether it has been contaminated during processing. Also, if it's grown in a field where there's some cross-breeding, not intentional, that where some of the wheat gets mixed in with the oats, and then you can't really separate that. Types of wheat flour would be whole wheat flour, bread flour, white flour, and within the white flour you have semolina, durum, all-purpose, pastry, and cake flours, which we saw on the previous slide. You have graham flour, ancient grain flour, high gluten flour. Types of gluten-free flours would be potato flour. You can have soybean or garbanzo bean flour, almond flour, coconut flour, walnut flour, and then grain or pseudo grains, which would be your non-grasses, are listed here. You can make flour out of all of these. Your treated wheat flours would be aged flour, which would be unbleached, bleached flour, which is typically what you see, phosphated flour, self-rising flour that has a leavening agent combined with the flour where you don't use a separate ingredient for leavening, instant flour, or enriched flour. So now we're going to talk about the crumb and the leavening agents. So there's 3 ways you can leaven a baked product. One is a physical leavener where you have air and steam. Okay, so what happens is you have your gluten, which is the protein that's going to trap the air and steam. And as the product is rising, because of the steam, the gluten then traps it and sets up because the protein will become rigid when it is baked. A biological leavener would be yeast and bacteria. And then a chemical leavener is very common to use a baking powder and baking soda. One way that we can use air as a leavener would be by incorporating air into an ingredient that then gets combined with the flour mixture, such as egg whites that are beaten to a stiff peak or a soft peak even. But if you carefully fold that into your mixture, the air that's trapped in the egg whites because of that protein will work as a physical leavener for your product. In figure 18-11, you see the role of leavening in bread volume and texture. So take a look at this. This is your crumb. This would be the leavened bread versus unleavened, which, unleavened bread would be very dense. Definitely not leavened by air or steam or anything else. And on the other side here, we have well-leavened bread, poorly leavened bread, a little bit closer up. So it's drilled down a little. You can see the crumb, how dense the poorly leavened bread is versus the well-leavened bread with these open cell structures. I mentioned already about physical agents to help the dough rise, which would be using air that you can incorporate into one of the ingredients that gets folded into the flour mixture. Steam would be coming from the liquid in the flour mixture. Yeast feeds off available sugar in bread. Yeast produces carbon dioxide and ethanol or ethyl alcohol through the process of fermentation. Yeast is available in several forms. Now, this is very important. It's classified on the basis of activity. So you have active yeasts and you have inactive yeast. The active yeast is used for leavening. The inactive yeast can be used for nutritional value and flavor. Figure 18-14 shows you yeast activity related to temperature. And what you'll see here is at very low temperatures, like below freezing, you're not going to see activity of the yeast. And at very high temperatures for the yeast would be like 131 to 140 degrees Fahrenheit. You won't see activity. Higher than 140, the yeast actually dies. So what is the optimal temperature for yeast activity? We're going to see the optimal fermentation occurs between 81 and 100 degrees Fahrenheit. However, right below that, the activity is still pretty good. So this is the range you want to use. Now, what we happen to know, if you're in a bake shop, they probably have a proofing box which controls the temperature. But what happens at home a lot of times is you would put your yeast, your flour mixture with the yeast that's been kneaded and everything. You put it on top of your stove with the oven on, but the flour mixture's on top of the stove, and you cover it with a dish towel, let's say, some type of cloth to trap the heat in there. And the yeast it'll cause the flour mixture to rise as the fermentation occurs. Here is an image of fresh yeast, older yeast, which has been in dry storage, and older yeast that was in airtight storage. In figure 18-16, we're seeing that they've used the fingernail scratch test on the surface to see about the freshness of the yeast. You can see. Another way of using leavening agents would be a bacteria, which would be a starter culture of microorganisms. This is usually bacteria and or yeast used in the production of certain foods, such as sourdough bread, cheese, and alcoholic beverages. Or baking soda, which is sodium bicarbonate, yields carbon dioxide in the presence of moisture and an acid. So if you're going to use baking soda as a leavening, there has to be some type of acid or acidic ingredient. Often that is vinegar, or it could be lemon juice. If you're using pure baking soda, you would want to use 1/4 of a teaspoon to leaven 1 cup of flour. So if your recipe had 2 cups of flour, you would use 1/2 teaspoon. And I want you to just take a look at the bottom here at baking powder. So baking powder is actually baking soda with an acid already added, so you don't have to add the acid or the acidic ingredient. There's fast-acting baking powder, single-acting, slow-acting, double-acting. And then potassium bicarbonate replaces sodium with potassium. This leavener is for people on low-sodium diets. There is a slight aftertaste, and it's more expensive than baking soda. Let's look at the role of sugar in a baked product. Of course, it contributes sweetness, but it also influences the volume, moistness, tenderness, color, appearance, and caloric content of a baked item. There are different types of sugar. As we know, there's granulated sugar, which is usually what you see at home in somebody's sugar jar or sugar bowl. There are several types of sugar that you're likely to see. Granulated sugar is mostly what you would use at home in a baked product. But also, you might see powdered sugar that's often used in making icings. Or there's brown sugar, which is often used as an ingredient in foods like chocolate chip cookies. So essentially, you would follow the recipe to see what type of sugar you would need to use. There are problems if you use too much or too little. These are important. These are the types of questions that you would see in a food science section on an RD exam. These are basic food science. This is basic food science information. So too much sugar might cause the baked product to fall, have lower volume, a coarse grain, gummy texture, and excessively brown crust. If there's too little sugar, you might have dryness, reduced browning, lower volume, and less tenderness. These are important. We'll learn more about salt at some point. Salt plays an important role as well. Okay, so what you see here, figure 18-19, you could do this in a food lab experiment. This is what you would see. On the far left here, you see 0% sugar, followed by 2%, then 5%, then 10%, 20%, and 30%. Also, if you use too little sugar, you can also have a problem. Figure 18-20 shows what happens when you use excess sugar, and that will decrease the cake volume and result in a gummy texture. It's important to use standardized recipes in an institutional setting because you don't really have time or money to reproduce these items if they fail. So you use proven recipes, and that's a whole nother thing to learn about. Okay, so let's talk about salt. Salt adds flavor. It produces a firmer dough. It improves volume, texture, evenness of cell structure, prolongs shelf life, and controls yeast growth. Again, very important things to know. Salt makes the dough more elastic. You see this in figure 18-21. Salt was added to the dough on the left, making it much more pliable, which aids in gluten formation. No salt was added to the dough on the right. That's dramatic and good to know. Figure 18-22 also will show you that salt influences dough firmness. On the left, you have no salt, and on the right, you have double salt. And in the middle, you have just the right amount, a normal amount for your recipe. Other flour mixture ingredients, we have flavorings such as flavor extracts of all kinds, vanilla, almond, lemon, all kinds of flavor extracts. We also can use cocoa, melted baking chocolate, fruits, spices, nuts, and other flavorings. Another two very important ingredients are liquid and fat. You must have liquid in your flour mixture to hydrate the starch. It can be water or milk. Too much, too little liquid causes problems. Too much, you have very moist dough and low volume. Too little would be dry with low volume, and this would stale quickly. I want you to think back to the video insert of the baker and showing you the various hydration levels of the dough that he was working with. Figure 18-23 shows you how fat influences the volume and texture of loaf bread. On the left, there's no fat, that would be fat-free. On the right, 1% fat. And that's, again, pretty dramatic difference. Fat physically interferes with the development of gluten. It creates a more tender crumb because it physically interferes with the development of gluten. It lubricates the dough and influences volume and texture. So here you have more information about fat, the functions of fat. So we know that the fat in the recipe of the flour mixture improves volume, improves strength, crumb, and flakiness, improves flavor and color, and delays staling. We should add functions of fat in the correct amount, the correct percentage proportion in the recipe. Figure 18-24 shows you how bread stales. So remember starch molecules in an amylose straight chain, which you see above the fresh bread image there. The straight chains, that's amylose. And then amylopectin is the branch chain. Amylose and amylopectin are found in bread taken right out of the oven, in which they are swollen and randomly positioned. As the bread cools, the amylose molecules, which are the straight chain, start to come together and crystallize, and that changes the texture of the bread. If you can remember amylose is straight chain, if you can figure out some way to remember that, or if you can remember amylopectin being the branch chain, that would make this all make sense. Because if it's a straight chain, as we've learned previously, they can line up and pack more tightly than branch chain, which obviously can't do that because of the branches. Several days later, the amylopectin molecules come together and crystallize. It takes them longer because of the branch chain. This further changes the texture of the bread. If you reheat stale bread, it will reverse the process to some degree, but it won't do it forever. So you can get away with it a couple times and then it's really too far gone. Fat is such an important ingredient in baked goods. Let's talk about the types of fat that we can use. Shortening, such as Crisco, which has a lot of trans fats. Unsalted butter. Margarine, which has some trans fats. Sometimes you can use oil and lard, depending on the recipe. These fats, as you remember, are hydrophobic, so you need an emulsifier there if you want to increase the volume. Oil coats flour too thoroughly, so it's not usually used, although you can use it in cakes and quick breads. Figure 18-25 shows the emulsifier's influence on the pour pattern and volume of loaf bread. That's also called the crumb. So what you see here, if there's no emulsifier, you will have a less consistent crumb. Other things to consider when using fat as an ingredient would be the temperature of the fat. In biscuits, for instance, if you were to use shortening, you want it to still be solid, and then you use cutting actions to cut it into the flour. You also might look for lower fat alternatives. There are several recipes going around that are often used in food science class where the fat is substituted with applesauce, for instance, or black beans even. You might have heard of black bean brownies. Those are lower fat alternatives. A lot of times when those are taste tested, the lower fat alternative comes out ahead. Again, if you have too much or too little fat, you will have a problem. Too much fat makes the batter too fluid, weakens the structure, and decreases volume. Too little fat, the batter is resistant to expansion during leavening, and you will end up with a tougher crumb. We've talked about adding an emulsifier. Eggs happen to be a really good emulsifier. They enhance the structural integrity of flour mixtures, again because of the protein as well, and they contribute to leavening, color, flavor, and or nutrient content. Too much or too little, again, will cause problems. If you have too much, excessive amounts of egg, you'll have a rubbery, tough product. If it's too little bit of egg, you'll have insufficient volume, inferior structure, color, flavor, and nutrient content. 18-26 shows you the influence of eggs on the volume and texture of loaf bread. On the left, you see a bread that's baked without egg content, and on the right, with whole egg. In food science, often you're looking at what can be substituted for various ingredients to either improve the nutritional content, to make it more suitable for special diets, or just good health in general. Eggs are one of the things you will often experiment with to learn what else could work in the place of egg. So be on the lookout for that. And finally, we have commercial additives in baked products and in flours. You have aging or maturing agents, dough conditioners, reducing agents, oxidizing agents, emulsifiers, mixing time reducers, and enzymes. In flours, you might see antioxidants added, BHA, BHT, vitamin E, vitamin C. You might see mold inhibitors, calcium or sodium propionate, and yeast inhibitors such as benzoates. It's important to understand what the additives are doing in the flour and in the flour mixture so you understand why it's there, what it is, what it does. If the additive is in the flour itself, you don't have a lot of control over that, but if you produce your own baked products at home, you can avoid some of the commercial additives to the actual baked products. Now let's talk about preparation of baked goods. Again, all of this is classic food science information that you're expected to know. A dough is a flour mixture that is dry enough to be handled and kneaded. You saw an example of that. Batters are flour mixtures that contain more water than a dough and whose consistency ranges from pourable to sticky. Drop batters are those that you might take a spoon, like drop cookies, you take a tablespoon or whatever size they say in the recipe, and scoop up part of that batter and then drop it on the pan. You might also even use a scoop that has a handle that helps you to release the dough so you have more uniform cookies if that's what you're making. Drop biscuits usually don't come out looking perfectly symmetrical. Usually for those you would use the kneaded bread. For those you would use a kneaded flour mixture and a cookie cutter or a biscuit cutter. A pour batter is one that you can pour. For instance, pancake batter, you pour it. Cake batter is poured. And other batters that you can pour would be in that category. Now let's take a look at figure 18-28. Here you find doughs and batters that are flour mixtures that differ in their liquid content and general use. And you're looking at ratios here, the ratio of liquid to flour. Let's start with doughs. Let's talk about cups just to make it easy. 1 cup of liquid to 4 cups of flour would give you a stiff dough. This is used for pasta, pastry, pie doughs, some cookies, especially if you're using a cookie cutter. A soft dough would have the ratio of 1 cup of liquid to 3 cups of flour. Here you have biscuits, rolls, scones, some cookies, and yeast dough. Moving over to batters, and you see the cutoff there. 1 to 2 would be 1 cup of liquid to 2 cups of flour. That would give you a drop batter. Cream puffs, which you would put in a piping bag and squeeze out in a certain shape. Muffins, which if you've made muffins, you know it's not really a pour batter. You do have to use a spoon or a measuring cup or something to scoop it out and put it into the muffin tin. Quick breads, which would be like coffee cakes. Well, there's coffee cakes. And some cookies would fall here. And then the pour batter, the ratio is 1 to 1. 1 cup of liquid to 1 cup of flour. And here you have pancakes, popovers, shortened cakes, some cookies, and waffles. So if you make cake batter, you can definitely pour that into the pans. Some cookies, which I don't think you're going to see very many cookies with a pour ratio of 1 to 1, but it's possible depending on what it is. Waffles are in the same category with pancakes, but usually a waffle recipe will have a little bit more fat. So what happens during the preparation of baked goods while they're heating? Gases expand and create pressure that stretches the elastic network of gluten, which remember is a protein. And what do we know happens when proteins come under heat? They harden. So you're going to create a structure that will hold up and hopefully not fall if it's done right. So then as the product cools, it still will hold that crumb texture that you want. The baked product rises until heat melts the fat, gelatinizes the starches, coagulates the flour, eggs, and milk, browns the outer surface, and then the structure sets and cooking are complete. That's all what happens to create the structure and the texture and the crumb that you want. At high altitudes, the lower atmospheric pressure lowers boiling temperatures and raises the amount of water lost through evaporation. And you will see modifications of recipes for high altitude settings. Now, how do we store flour and flour mixtures? One way is through dry storage, or it can be frozen. So in summary, we explained flour composition and the functions of its starch and protein. We outlined unhealthy reactions to cereal grains or their flours and how they differ. We listed the 5 major steps of milling flour. We discussed the various classifications of flours and how wheat flours can be classified by protein content. We summarized the various ingredients and functions in flour mixtures. We defined the differences between doughs and batters, changes during heating, and high altitude adjustments. And we provided some instruction on how to best store flours. That concludes this lecture. See you next time.